Welcome everyone, and also thanks to all my colleagues, friends, researchers listening to this presentation. I'm Ravinesh. Basically, this first slide is just about who I am and where I work and my homepage. So I'll probably move to the next one. So my research group is basically called Advanced Data Analytics Research Group. It's not a center or an institute. It's actually under the Institute of Engineering and Space Sciences, and obviously Institute of Life Sciences and Environment. So USQ's got two major institutes under which my research group falls in. Obviously, this is quite an informal research group. We've got a very diverse team of researchers, largely postgraduate students and obviously academic supervisors working on different projects. You would see the motto of my research group is, sky is the limit. We try to do good things and good research. Hopefully I can share some of those with everyone today. So as the logo suggests, we are very diverse. Our research group is quite passionate about data science, AI, machine learning, whatever you might want to call it. We'd never come up with a consistent name, or as in, obviously, but this is data science. I would call it data science because you're giving a talk to ADSN. Okay, so moving forward, I have a 10-minute talk. So that's my team, which involves lots and lots of PhD students, in total 17 students currently, and obviously a lot of other academic supervisors. So I'll just go through. We've had a lot of graduates as well. In total, 27 students have graduated over the last, I think, 7 years, in which I'm leading this group. So that's a bit of photos there, but I'll move to my next slide. So obviously, as I mentioned, we are passionate data scientists. We're doing lots of research with machine learning, AI, PhD and master's projects. We've had 27 projects that have finished. They comprised of full research degrees, master's and PhD, as well as coursework research, which requires a smaller research component. So in terms of current projects, we have 21 students. I would mention, I said 17, but actually 21 research projects going on. It collaborates with a wide range of supervisors across USQ and also across a number of external supervisors from other universities. So, and there's about 15 of them. Now, we call ourselves researchers, so we develop collaborative research projects. We call ourselves research students or research higher degree researchers, basically under the 2 master and PhD degrees. We also engage with industry, largely in internship programs. Okay, so just a few things that I wanted to put as a project highlight. I wouldn't be able to go through in great detail about these, but I've just put titles there and talk through them. There is a project that we are doing on signal processing algorithms for quantum computers. This is a collaboration with CSIRO. We're trying to look at graph signal processing with machine learning. Mainly, we are trying to build cutting edge algorithms for quantum computers. So quantum computers are obviously seen as a future. Not that it's more important than other areas, but it is obviously one of those focus areas, and we got a beautiful collaboration with CSIRO. There is a work that the second project involves the Australian Defence Department. It started last year. Well, it aims to build artificial intelligence approaches for communication. So it is a very, in a very broad sense, I would say the aim of this project is to build a universal radio for communication systems. And we are trying to develop what we call very fast, low latency algorithms that can really do, transfer message with minimum loss, with optimal efficiency, both in time and accuracy. So, if we put a number 1, we need to get a number 1 on the other end. Obviously, that's not perfect, so it's never be achieved, never going to be achieved, but we have an ambition to do such research. There is another project, and that's on solar ultraviolet index prediction. So obviously UV is a big concern for Australia. The sun is above us, and Queensland and the whole of Australia is under things such as eye disease and skin cancer coming from this solar ultraviolet radiation. So my research group is working on a project. It's actually another PhD project to actually build a cloud image based model that can, tell us the UVs low and high under these kinds of cloud conditions. So, when clouds come over, you've got a shadow. You generally reduce the solar radiation reaching the surface of the Earth. But in some ways, clouds also amplify the effect of UV on the human skin. So, there's a project that looks at that. I'll probably move on. There is another one that looks at, modeling evaporation in grazed woodland. So that's a new student who just started this year. She's looking at lots of measurements from flux towers, satellite, remote sensing. So integrating various data sources to actually come up with some decision systems in groundwater modeling. So looking at things such as, um, uh, environmental impacts, I suppose I would say, in Queensland. And then that's largely a remote sensing kind of work, but we're using AI to achieve those outcomes. Now I'll just keep moving. There is this next slide on my project highlights too. We're looking at remote sensing methods and deep learning for mine rehabilitation. Obviously Queensland is one of those that's got lots of mining activities, as is Western Australia and other parts of Australia, and several other parts in the world. There is a PhD project that's looking at LiDAR remote sensing data, remote sensing imagery, and it's trying to actually map the disturbed mining sites, to tell us, okay, here is the maximum disturbance, and here is, okay, the sites are recovering, here's a region where they are really need attention. So these sorts of things. And so that's one project. There is another one on drought prediction, looking at basically evaporation and evapotranspiration index. So that's an indicator of how, dry or wet the soil is. And we are looking at forecasting drought severity, largely with the implications for water resource management. There is a project that looks at algorithms for early warning system for air quality, and the actor is leading that great work. We're looking at various pollutants, such as particulate matters 2.5, 10, visibility, various other pollutants that can be modeled with AI techniques. And that's work we are actually looking at satellite data. How can satellite data be integrated with an air quality forecasting system? So that's another of the project highlights in my research group. I'll keep moving. Obviously, this slide brings me to what we call some of the artificial intelligence and machine learning techniques that we specialize in. So I would put that in inverted commas. We are not specialists. We're still learning, and everyone in the group is learning, but we are dealing with models, or rather hybrid models for AI and machine learning applications. So the pitch there is to integrate single models, several single models for improved prediction. So when I say improved prediction, can we improve the accuracy by combining two different approaches or three different approaches? So more like hybridization, which is quite common in environmental modeling areas and perhaps other areas too. We're also addressing some of the issues in non-stationarity in data sets. So if you look at, let's say, the last 50 to 80 years of temperature, air temperature, there has been a generally rising trend, 0.2, 0.3, 0.4 degrees. Now that creates what we call a non-stationary data set. It doesn't have a regular trend. We are looking at data decomposition methods. So can we split those patterns, and can we use the features from those split up data to build models that are more resilient, more accurate? We're also looking at what we call the curse of dimensionality. Now, this is something that's not just in environmental areas, but in every area where there is big data, there is too much. So data is often redundant. And then we don't want to fix all those data in the models, because obviously the accuracy of the models, both in the computational accuracy as well as the speed and the predictive ability, goes down. So we are looking at feature selection. So can we get the best of the best features? If you've got 100 variables, what is the best 10 of those? What is the best 20 of those that can lead to improved prediction? We're dealing with low latency. So low latency, high throughput models. This is something related to our defense project. We're looking at super fast models. Can we achieve that through various improving various algorithms? So within the architecture of those algorithms, can we do that? Because low latency generally means very fast, and those things are needed in real-time applications. We're also looking at cloud effects in photovoltaic power. systems and also UV predictions that I mentioned previously, and obviously satellite data sets in ground-based environmental modeling areas. So there is a vast range of applications that we are looking at. Okay, so in terms of other projects that are already completed or ongoing, we've worked on wind speed prediction, energy demand, and a whole range of other things I've put on the slide there. It's a highly diverse research group, and I suppose the main aim of our research group is to provide some sort of decision systems. We haven't really built anything, such as the great thing that Dharmendra has pointed out, which was fantastic. So we haven't achieved that yet, but our main purpose is to advance algorithm design. So can we improve those algorithms, and somebody else can go and make a new decision system out of it. So that is the focus currently. Okay, so in terms of engagement with industry, we're very fortunate to have a number of our PhD students, PhD researchers connect with industries in Australia. Largely, this has been possible through the Australian Postgraduate Research Program, APR internship, which I'm sure some of us will be aware of. We've had a student, Darren, who's worked with Senators Australia on AI and machine learning for signal processing. So in particular, they're interested in improving the predictions using images. We've had a project with CS Energy and a Queensland company on bias correction for weather models. So, weather models are very useful for solar energy generation and monitoring. So they look at 2-hourly, 3-hourly, 6-hourly inputs from global forecast models, and can those be used to improve or rather to provide a time ahead prediction for solar generation. We did a project with CS Energy on that. There is a project Farina is leading with CSIRO, and that's again on quantum computing, machine learning approaches to improve obviously applications to quantum computers. ECTA has also led a project with Australian Defence Science and Technology, and there was an initial seed project that has led to a 3-year project that another of our PhD researcher is now working on. So we had a project with the Australian Bureau of Statistics that dealt with data sets for multi-purpose surveys. So, in that project, they looked at you've got surveys going on, you've got census, and I suppose all of us have done our census in the last 2 months. Now, what is the potential for machine learning to improve those samples that we get and to make some better sense of missing data and those sorts of things? So, and then obviously we had a Queensland government project on automation of government transactions. So looking at procurement and other purchases and things, and can we develop a system to actually automate some of those analysis? So, I mean, these were very short-term, 3 to 5 months work, but they've empowered a lot of our PhD researchers in learning the skills and connecting them to industry. So I think that was a fantastic opportunity for our group. I'll just keep moving. So this slide here, I just thought I would probably put some questions and, the challenges and opportunities that we face. I think, AI and machine learning is growing very rapidly. Obviously, the driving factor of that is the data that's available. There is huge amounts of electronic data or can be made available. So things such as, can we make an AI model a human-centered decision maker? Obviously, are they explainable? Because if we talk to physical modelers, people who use physics-based models, often there is a question. You're doing a black box modeling. Are you able to explain the physics behind it? So questions such as, can we make a machine learning model explainable, and further go into make them interpretable? Can we interpret that information accurately? So these are some of these areas that, again, our research group is working on, as bits and pieces in every focus project that we do. Are machine learning models socially just and ethical? And that links to my question number 6. What is the future of AI models in very sensitive areas such as health, areas such as law, medicine? Do we like a computer giving us prescribed medication? Do we trust the computer? So these sorts of things, I think, is really our challenges. And I like question number 5. What is the future of AI models in terms of replacing our jobs? I don't think they will replace our jobs. I think it's all a matter of, enhancing the capability. But, people could still be thinking, if we have all automation, people are going to lose jobs. And probably that's then time to transition to more upskilling of our our people and our workforce with these new techniques. And perhaps these are the interesting things that we should be looking, or we could be looking at. Obviously, how do we deal with AI models that lack data? So often we see that the data sets are not labeled. We don't know where they come from, what do they represent, or is there enough data? Because I suppose AI and machine learning probably carries little value if you don't have enough data. So with some areas that lack enough data, can we do things such as data augmentation or other approaches? So these are some of those things that could be interesting for us as data scientists to think about in future. All right, so I just thought I might want to put a, it's not a show off. It's really just a bit of work that we got in a recent project with Defense, which I've talked a little bit about that. Making waves. Our group is now collaborating through a PhD funded project to help develop an intelligent radio system. And so that is has been the news in the last 1 or 2 months. And we have Chris Davey, our researcher on this Zoom, who's working on this project. Okay, so in terms of the outputs from our group, obviously I put a link there if you'd like to go through, or not go through, but rather catch up on some of those papers that could be useful to you. We've got a very strong focus on publication. Lots of our group members are PhD students, but they generate publishable work. So I've just put some slides there on what we've published in. And finally, I thought I would put this slide up here. I saw that come up from, somewhere in the Australian government website on the future of a digital economy. So, and I think the initiatives that David and his team are running on this ADSN is really, really useful in the sense that data science is going to, or AI, if you like, is going to be one of the big investment areas. So it is a great initiative to connect with everyone, to know what we are doing and to learn and to probably exchange that knowledge. So, I think the Australian government has a very big plan on supporting AI. I mean, I think there's talks about a national AI center, which can drive lots and lots of AI expertise, graduate positions, PhD researchers, and even postdoctoral research opportunities. That's going to be very big focus in terms of the government initiatives and initiatives such as lots of funding opportunities, I suppose, that'll be in this space. So networking, collaborating, and I think knowing what each other are doing and doing something better to build decision systems, or whether they are direct applications or whether they're advancing knowledge. I think those things will be really the focus in the future. So with that brings me to the end of my little, I suppose 10-minute talk, David. And obviously looking forward to possible engagements and collaborations. So please feel free to contact us. These slides will be available through the, I think David will make them available later.
Sure.
So please.
Absolutely. Could I just ask you to just go back a few slides to those 6 challenges that you put there before the publications? The one thing that I would observe about that is that each one of those challenges has a human being in it.
Certainly.
I think it's really fertile ground for further discussions that we might have.